need to do now is find equations for tangent lines and normal lines. So in each case, we've got to find slope at the indicated point. Slope, of course, is the first derivative. So number 45 looks like y equals square root of x squared minus 2x. We want to find the indicated, or where x equals 3. The indicated point, you need to find the tangent line. So tangent line first, normal line second. Take this as all parentheses to the 1/2. So we'll find dy dx. And of course, the first derivative is our slope. And that's going to be equal to 1/2 x squared minus 2x to the negative 1/2 times the derivative of the inside, which is 2x minus 2. So there's our slope. All in terms of x, we'll put in x equals 3. Notation, dy dx. This is an evaluation symbol. Evaluated at x equals 3 is going to be 1/2 times 3 squared minus 2 times 3. The negative 1/2 times 2 times 3 minus 2. That's going to be 9 minus 6 is 3. So it's going to be 1/2, let's see, 1 over the square root of 3. And this will be 6 minus 2 is 4. 4 and 1/2 will cancel to make it 2. So that means 2 over the square root of 3. I'm going to write that as 2 radical 3 over 3, but no big deal. Alright, so we have our m. We have an x. We do need a y. And the y we're going to use, if we're on this point, pardon me, if we're on, at this point x equals 3, then there's corresponding y at the line. And we have our tangent line slope there. So we'll look at y equals mx plus b. Find our y. So if we evaluate at 3, there's going to be 9 minus 6. So that's going to be the square root of 3 is equal to y. That's radical 3. Now equal 2 over radical 3 times x, which is 3, plus b. And we'll solve out for b. So this is radical 3 equals 6 over radical 3 plus b over radical 3 minus 6 over radical 3 equal to b. I'm writing our equation just like we have up here. We'll keep the y, we'll keep the x. Now our m and b are solved for. We have y equals m, which is 2 over radical 3, x plus radical 3 minus 6 over radical 3. Actually, 6 over radical 3, I can reduce, can't it? That's y equals 2 over radical 3, x plus radical 3. 6 over radical 3, 6 is 2 times 3, and 3 is radical 3 times radical 3. So that radical 3 can cancel this one, so there'll be 2 radical 3. That's 2 radical 3. Oh, and those go together nicely. How convenient. Y equals 2 over radical 3. X plus 2 radical 3 and 1 radical 3 is 3 radical 3. That's the equation of our tangent line. We're going to do the exact same process as up here with our normal line, except we're going to use the negative reciprocal of the slope, and we'll keep the y and the x. So, I'll take up some more space here. So, our y remains the same because we're going through the same point. Radical 3, instead of 2 over radical 3, that'll be negative radical 3 over 2, opposite reciprocal, times 3 again, so our y and x stay the same, again plus b, and so that'll be radical 3, this will be 3 radical 3 we'll add, plus 3 radical 3 over 2 equals b, and so our equation would be y equals, we use our tangent slope, of course, or I mean our normal slope, not the tangent slope. Negative radical 3 over 2 x plus radical 3 plus 3 radical 3 over 2. And if these two went together, these two will go together too. That's really 3 halves radical 3. So that's 1 radical 3 and 3 halves radical 3, that make 5 halves radical 3. And here is our equation for normal line. All's well and good. Moving on, number 46. Same instructions, except for this time our curve is given by y equals 4 plus the cotangent of x minus 2 times the cosecant of x. Double check I have that right. 4 plus cotangent of x minus 2 cosecant of x. Yep. So slope equal to first derivative of 0. Derivative of cotangent is negative cosecant squared. Derivative of cosecant is negative cosecant cotangent. Now we've already got a negative, so we plus 2 cosecant cotangent x. And we need a point at which we're doing this, of course. Not write that down. This is that x equals pi over 2. Yep, pi over 2. So x equals pi over 2, we'll evaluate our slope. So our first derivative evaluated at x equals pi over 2. So that's going to be negative cosecant squared of pi over 2 plus 2 times cosecant pi over 2 cotangent pi over 2. And I don't know these values so well, but do know that for the negative 1 over sine squared pi over 2 plus 2 of 1 over sine of pi over 2 times cotangent. I don't know my cotangent values, but I do know my tangent values. Worked hard in the unit circle. And into pi over 2. Alright, so the sine of pi over 2, talking straight up in the unit circle, right? Here's 0 over 2 pi. Pi over 2 is 1/4 of the way around. That equals 1, so that's still 1 when it's squared. It's going to be negative 1 here. That's going to be 1, so we can just skip it. Tangent of pi over 2 is undefined, but the cotangent, so we're not going to be able to evaluate it like this because it's already undefined, but the cotangent I believe is going to be 0. Let's, instead of doing that, let's do a cosine over sine. Cosine of pi over 2 over sine of pi over 2. Cosine of pi over 2 is 0, sine of pi over 2 is 1, so 0 over 1, so that's 0, all this is 0. So our slope just equals negative 1. That's our slope. Now we need y equals mx plus b. Our slope is negative 1. Go down that so far. Our x is pi over 2. So we'll solve for in a second. I'll have to find out where our corresponding y value is at x equals pi over 2. So pi over 2, pi over 2. So that would be 4 plus cotangent of pi over 2, we discovered was 0. Minus 2 times cosecant of pi over 2. We realized that was 1. So that would be 4 minus 2 is 2. So our y value is 2. 2 equals negative 1 pi over 2 plus b. That means that our b equals 2 plus pi over 2 as such. So now that means that y equals negative x plus 2 plus pi over 2. The equation of our tangent line. Equation of our normal line. Another y equals mx plus b. Has the same coordinates, so the y still equals 2, the x still equals pi over 2. Our slope is the opposite reciprocal of negative 1, which is this positive 1. So that means that our b in this case is going to be 2 minus pi over 2. And the equation of our normal line, y equals positive 1x